Welcome to Dr. Anima Upadhyay's Chemistry in Technology lecture series. In today's video, we will discuss about a very important process, sorption. Sorption is a phenomenon which includes absorption and adsorption. But before I start this topic, I will request you all who are watching my video for the first time and those who have not subscribed my channel to please subscribe it. Also, don't forget to like and share my video. Let us start about sorption. So, as I said, sorption includes both absorption and adsorption. Some of my viewers have requested me to explain the process adsorption. But to understand adsorption, one should know what absorption means. So, first I will explain absorption. It will be easy for the students who have not understood absorption and adsorption well. Then in my next video, I will explain adsorption and the differences between the two processes, absorption and adsorption. So, what is absorption? I'll take one example, very simple example. Suppose some liquid spills on your table. Can you ignore this? You cannot. So, what you will do? You will take a towel or a sponge wipe or some cotton and you will put it on the liquid. The liquid will get soaked into the towel or the sponge, and then you will squeeze the towel or the sponge in the sink and repeat it till the table becomes dry. This soaking of liquid in the towel is an example of absorption. So, how you can define absorption now? Absorption can be defined as the entry of molecules or atoms or ions of one material into another material where it is retained. This process is called absorption. The molecules or atoms which enter another material where it is retained is called absorbate, and the material which retains the absorbate is called absorbent. Now, taking the example of liquid and towel, which is the absorbate and what is the absorbent here? The liquid is the absorbate and towel is the or sponge is the absorbent because the liquid is retained in the towel. So, liquid is absorbate, which is absorbed, which enters the towel and it is retained in the towel. So, towel is the absorbent. Now, the absorption is of two types, chemical absorption and physical absorption. Physical absorption is the example of water entering the towel, where no chemical reaction has taken place and it is a reversible process. The liquid is retained in the towel and on applying force like squeezing, the liquid can be removed from the towel, not 100% but to a great extent. The liquid which enters the towel does not undergo any chemical reaction. It is held by simple van der Waal forces, which are weak forces in the absorbent. But the chemical absorption is irreversible because here the absorption takes place with the help of chemical reactions. There's a chemical reaction between the absorbate and the absorbent. For example, purification of natural gas. Natural gas, which is mostly methane, it may contain hydrogen sulfide and carbon dioxide as impurities. Now we want to remove the impurities from the natural gas. So we pass the natural gas through ethanol amine, which absorbs hydrogen sulfide and carbon dioxide and removes it from the natural gas, thus purifying it. Similarly, removal of moisture from the air or from any material, we use anhydrous calcium chloride, which is an example of chemical absorption. The flue gases, which comes out from the chimneys of the industries, contains, besides oxygen, harmful gases like carbon monoxide and carbon dioxide. So these gases are absorbed on materials like ammonical cuprous chloride. Carbon monoxide is removed. Potassium hydroxide and sodium hydroxide is used for the removal of carbon dioxide, and oxygen is absorbed on alkaline pyrogalol. So in this way, these chemical and physical absorption processes are extremely important in various industries, in pollution control, in purification of gases and liquids. Also, it is used, absorption is used in many biological processes, which includes osmosis and diffusion. The absorption of substances from intestine into the blood. So there are many biological processes where absorption plays an important and significant role. So we can conclude that absorption is a bulk phenomenon. Here, the absorbate in the form of liquid or gases dissolves and permeates in the holes, through the holes present in the absorbent into the bulk spaces, and it is retained there in the absorbent. It is uniformly distributed in the absorbent. The absorbate is uniformly distributed in the absorbent and it is retained there. The absorption is an endothermic process because it increases the energy of the system. If you want to remove the absorbate, it requires energy. As I have told, if you want to remove the liquid from the towel, you have to squeeze the towel, you have to apply force. So, because it is a bulk phenomenon, therefore, you have to apply force to remove the absorbate from the absorbent, from its bulk space. Therefore, it is an endothermic process. The absorbate accumulates in the bulk of the absorbent, and this filling depends upon many factors such as the concentration of the absorbate, the contact time between the absorbate and the absorbent, the surface area of the absorbent. The larger the surface area, the more will be the absorption, because it is the pores which are present in the absorbent material which allows the permeation of the absorbate into the absorbent and retains it there. I hope I have made you understand absorption well. In my next video, I will talk about adsorption, which is another important process. And as I said, absorption and adsorption goes simultaneously. So don't forget to watch my next video on adsorption too. Adsorption is very important for engineers, scientists, both. Keep watching my videos and take care of yourself.